Greetings everyone. My name is Dr. Uneem Kasar, and today I'm going to present my paper on spatial-temporal analysis of traffic accidents Bahrain using Geographic Information System, which is also known as GIS. I'll start with my introduction. I'm an associate professor at the Department of Civil Engineering, University of Bahrain. You can see my contact information and my area of specialization in transportation planning. And this pretty much falls into my area of expertise. So first of all, let us look at the significance of this research, why this research is important. The problem of traffic accidents is a global issue, and it has been recognized by WHO as well, which forecasts that if the traffic accidents continue at the same pace, they could become the 8th largest cause of accidents throughout the world. That would obviously include Bahrain as well. The research gap which was found in this area was that most of the studies focus on the causes such as human vehicle load factors, but there's very limited literature about studying the changes in traffic accidents over time. And locally, there is an overall gap related to traffic accidents and their studies about Bahrain. So this prompted me to do the study about traffic accidents in Bahrain. And the primary objective of this case study is to design a geodatabase and then use it to do the spatio-temporal analysis of traffic accidents. I focused on the fatal accidents, and the period of study was from 2012 to 2018. The key contribution of this research is the identification of high-risk locations which persist over time, and to track the temporal evolution and shift of accident hotspots over time if there is any. The ultimate goal is in the end to provide evidence-based insights for targeted interventions which can improve the road safety situation in Bahrain. So the methodology of the study mainly comprises of three main steps: the data collection, the geodatabase development, and then the analysis. So the source of the data was General Directorate of Traffic in Bahrain. A study period, as I already mentioned, 2012 to 2018. During this period, I found 482 accidents in the database. The geodatabase was developed using the ArcGIS tool, and the layers which were used for the analysis is road network and intersections. Intersections were created as nodes. The location of accidents which were provided in the General Directorate of Traffic database with the coordinates and the satellite imagery. So these layers helped me to do the analysis. And for people who are not familiar or not so familiar with GIS, layers are basically different sets of data which you overlay upon one another to do your analysis. Okay, so in the methodology, the analytical approach which was adopted was creating buffer zones around the accident locations, and the buffer zones had a radius of 500 meters, and they were created around the nodes or intersections. And for the roads, the buffer created comprised of 100-meter radius for arterial collectors. And this was done to basically focus on the influence area. So for roads and highways, it was narrower, but for intersections, as we know, that the influence area can be bigger. And the annual data was clipped as like a matrix function which we have in GIS. Okay, and this function gave the accidents which belong to each buffer or within the each circle of the buffer, and any node which had 2 or more fatal accidents was considered the red zone. So as I already mentioned, I'm focusing on fatal accidents, so 2 or more is quite a lot for one location, and the analysis was done year by year. So 2 fatal accidents in a year is quite a lot. So the findings, first of all, without going into the GIS, we saw a downward trend, especially after 2015. It seems to persist looking at the 3 years of data we had. So what happened in 2015? There was a big change in the traffic laws with more severe punishments for traffic violations. And this seems to have a good impact on reduction of traffic accidents. And I believe that this trend has persisted. I have done the analysis in some other papers for the more recent period, but this trend shows a good impact. So the conclusion we can draw from this particular trend is border policies can effectively reduce the traffic frequencies. And the finding was the location of the accidents. So it was found that the urban arterials are the major locations where the accidents happen more frequently than other locations. And those other locations included intersections and local collectors. So this being said, that urban arterials have more share of accidents, which is even greater than the intersections, which is a troublesome statistic, because intersections are supposed to have more conflicts with traffic which is going in different directions, but urban arterials in terms of fatal accidents are taking the majority, and I believe even this trend is even persisting till now. Okay, so this particular observation shows or helps us to prioritize the interventions. Okay, so it tells us that we should focus the intervention on major highways, or at least we should give them the priority. Then another key finding was the persistence of certain locations over the period of time. So as I mentioned that I did the analysis over a number of years, and looking at that analysis, I found that there are some nodes which continuously carry high number of fatal accidents. So they were continuously red spots in a number of years. For example, there was a node 286, and this number is basically given by General Director of Traffic in their database. And this node 286 belongs to Dry Dock Highway and Heath Avenue, the intersection of these two highways. And it showed a persistent trend for 4 years. Okay, and you see that these 4 years are some before the changes in traffic laws, and 1 year after the change in traffic law. So, and there were other nodes as well which showed similar trends. So these persistent nodes, or these nodes which have recurrent traffic accident problems, they need immediate attention basically. So redesign, improving signage, putting speed cameras, or using any other traffic management strategy should be a top priority for these zones. Okay, then something which was unique to this study, that is the combination or the integration of spatial analysis with temporal trends. So you can see that the figure shows the red zones over the number of years, and there is some shift in these zones, like they are not the same over there. As I already mentioned, there are some zones which continue, but it's not the same with all the zones. Okay, so it's not like every year have the same number of zones exactly. Okay, so the early years the clusters were in the northern region of the kingdom, then in the later years they shifted towards the southern region of the kingdom. Okay, as you can see here, the difference between this one and this one and this one. Okay, so you can see some population going towards the southern region as well. And obviously these maps are just exhibitory maps. If you look into the GIS, it will give you a better picture, but the trend was that southern region is attracting more red zones, and the potential causes can be the opening of new development schemes in that zone or in that part of the kingdom, and which obviously would increase the traffic flow, consequently increasing the exposure or the risk of traffic incidents. So what we can do about it, traffic safety planning must be dynamic. So when we are considering the mitigation measures over the years, we need to consider the shift in development patterns and the traffic patterns as well. So the same strategy may not work because of what is happening in the kingdom. So on the basis of this study, we can summarize a number of insights. For example, we saw the useful nature of GIS as a powerful tool to understand the evolving nature of traffic accidents over the space and as well as over the time. We identified specific persistent high risk locations. We have seen significant spatial shift of hotspots from one part of the kingdom towards the other part of the kingdom over the years. And overall numbers are dropping, but the localized risk factors are still there, which is shown by the persistent or the recurrent hotspot locations. Okay, and this in the end proves the validity of the spatio-temporal analysis which was conducted in this study, and it provides a basis for continuing it in the future as well. And the advantage was very clear if you compare it to the static methods which have been more used over the years in the previous literature. Okay, so what can we do? What are the future recommendations? The targeted nodes which we have seen, the persistent nodes, they need immediate action. They should be dealt with at higher priority. The government or the authorities need to proactively look into the development patterns and their changes when they are making future planning. In terms of research, the advanced special statistics which were not used in this study, like kernel density estimation, it can be incorporated as well, which will further validate the identification of the hotspots, and incorporation of traffic volume data and land use data may shed light on the reasons of traffic accidents and their shifting and their evolution over time and over space. So this is it from my side. Thank you for listening. If you have any questions, you can send it on this email address. Thank you so much.